In this lesson, we're going to talk about optimizing storage space, how to make our storage devices in our computer work as fast as possible. We're going to look at this topic from two different perspectives. The first perspective we're going to look at is from the hardware level. What can we do with the hardware to increase our speed? And then we're going to look at it from an operating systems level. What can we do with our OS to make our storage devices operate as fast as possible? Let's talk about hardware first. From a hardware perspective, there are two things that you can do to optimize the performance of your storage system. The first thing you can do is to upgrade to the fastest hard disk possible. A lot of folks don't understand that hard drives come in a variety of different rotational speeds. Currently, the slowest drives you're going to see on the market run at about 5,400 revolutions per minute. Now, this rotation speed, the RPMs, dictates to a large extent how fast data can be written to or read from the hard disk drive. The faster the drive spins, the faster it can read data, the faster it can store data. This gets a lot of folks right here because usually when you're flipping through your Sunday paper and you come across an ad from your local computer store and they just have an unbelievable screaming deal on a big hard disk drive, a lot of times the reason they're so inexpensive is because they're running at a very low rotational speed. I know 5,400 RPM sounds like a lot, but in terms of computer hard disk drives, it's actually fairly slow. As a bare minimum, I would get a 7,200 RPM drive. Any slower than 7,200 and you'd really start to notice a performance hit. Obviously, 7,200 RPM drives cost a little bit more than 5,400 RPM drives. If you want to spend the money and you want the fastest possible, they make drives that run around 10,000 RPMs. Take a look here. The low end, we're talking about 5,400 RPMs. At the high end, we're looking at 10,000 RPMs. This disk can read and write data almost twice as fast as this one. It doesn't seem like it would make that big a difference, but it does. So if you're down here with a 5,400 RPM drive, you can dramatically increase the performance of your storage system by upgrading to the fastest hard disk possible. The second thing you can do is to upgrade your disk interface. If you want to stick with IDE, then you should see to it that your motherboard supports the ATA133 standard, which transfers data at roughly 133 megabytes per second. A lot of motherboards are around that are still running at ATA100, and I've even seen a few ATA66 systems around. I even have one computer at home. It's quite old. I bought it many years ago, but it's ATA33. Upgrading to a faster disk interface will dramatically improve the throughput of data to and from your hard disk drive. If you really want some speed, then you need to move away from the older ATA/IDE disk interface and upgrade to a serial ATA disk interface. By doing this, you can upgrade your speed to 150 megabytes per second and even faster. An important thing to remember, especially if you're dealing with ATA/IDE drives, you may have a motherboard that has an ATA133 interface on it, but if you go down to the computer store and you buy that drive that's on sale and it's a 5,400 RPM drive and it is an ATA66 or ATA100 drive, you're not going to get 133 megabytes per second out of it. You're going to get whatever the hard disk itself is rated at. So if you buy an ATA100 drive, even though you connect it to an ATA133 disk interface, it's only going to transfer data at 100 megabytes per second. So that's the way we can optimize our storage devices from the hardware perspective. Now let's shift gears and talk about the things we can do to optimize our storage devices from the software perspective. There's many things that we can do. One of the key things that you can do is keep your disk clean. In other words, get rid of stuff that you don't need. The key thing to remember in this regard, and this is a hotly contested statement I'm about to make, but I've observed it and I believe it is true, and that is the fact that a mostly empty drive is faster than a full one. Why is that? We'll talk about this a little bit more when we talk about disk fragmentation. A drive that is mostly full is a little bit slower because the hard disk interface has to hunt around all over the hard drive to A, find pieces of a file, or B, trying to find an empty space in which to save a file. It's not a big hit, but it is there and it is noticeable. Therefore, you should try to keep your drives as empty as possible. There's stuff that you got to have on the hard drive. You can't just get rid of everything. There's stuff that you need. The computer's there to do work for you. But there is stuff on your hard drive that you can get rid of. One thing you can do is to run disk cleanup frequently. Every time you open up a web browser and visit a website on the internet, the web page that your browser downloads is cached on your hard disk drive. All the graphics in the page are cached, and over time, it adds up. One page is not that big a deal. You're only looking at a few, maybe 20K at the most. But when you start having hundreds or thousands of pages cached on your hard drive, it can chew up a lot of space. And there are lots of little files all over the place that clog up the drive. In addition, anytime you delete something, those files are actually saved. Files are held in a special reserved part of the hard disk drive in your recycle bin, so that if you decide, oops, I didn't really want to delete that, I want it back, you can restore it. Well, if you don't really need those files, you should get rid of them by emptying your recycle bin. The disk cleanup utility is one of the best ways to do this. You could do all this manually, but it's really nice to go into the disk cleanup utility and run it, and it takes care of everything all at once. Another thing you can do is to remove unused Windows components. When Windows is installed, by default, a certain set of Windows components are included in the installation. And if the person who is doing the install customized the install, they might have more Windows components included. These components use up space. One thing you can do is to go into Control Panel, go to Add Remove Programs, and then go to Windows Components and deselect different components that you never use. If you don't use them, you don't need them. Get rid of them off the hard drive, and again, you clean up space that doesn't need to be used, emptying out your drive and increasing its performance. Getting rid of stuff that you don't use frees up space on your hard disk drive. When your hard disk drive has more free space, the disk interface can read information faster and it can write information faster. Another thing you can do that will really dramatically increase the speed of your disk is to defragment it. Now, to understand the need for defragmentation, you have to understand what fragmentation itself is. Understand that when your hard disk controller writes data to the disk, it scatters parts of the same file over different areas of the disk. This is called fragmentation. Now, it gets worse as time goes along. After you first install an operating system and start installing applications, your disk isn't fragmented very badly. The really bad fragmentation occurs over time as you delete files, add files, delete files, add files. Pretty soon, fragments are stored all over the hard disk drive. Fragments of the same file are often stored on a different sector of the hard drive than other parts of the same file. Let's take a look at how fragmentation occurs. Let's say we have a basic system here. This is a hard disk drive. We've done a basic install and we've used up this much of the hard disk drive. Let's suppose I come along and I'm using an application and I save a fairly large amount of data onto the hard disk drive. I might save files right here and right here, in addition to what was already written to the disk during the installation. So far, so good. Our files are fairly contiguous. They're saved in areas right next to each other on the hard disk drive. Time passes and I delete some files. Let's say I remove some components from my Windows system and I free up this chunk of the hard drive right there. It's no longer used. Well, the next time I open my word processing application, I go to save a file, it might say, hey, there's an open block right there. I'm going to stick that information right there. We're still doing okay. But then it says, you know what? We need to save some more information from that file, and it's actually too big to fit in there, so I'm going to put half of the file here. I'm going to put the other half of the file over here. And then time goes on, and you delete this file, and you're working with a different application, say maybe your PowerPoint application, and you're saving your PowerPoint file. And it says, well, this space is open, let's save it here. But, oh, it's too big. Let's save the rest of the file down here. Over time, as this happens over and over and over, pretty soon we have fragments of the same file located all over the hard disk drive, especially if it's a large file. We could have a piece of a file right here. We could have another piece of the file over here, piece of the file right here, piece of the file right here, and a piece of a file right there. When you open that file, say in your PowerPoint or word processing file like Microsoft Word or whatever it is, in order to open that file, the disk interface has to pull this chunk off the drive, spin the drive, pick up this chunk, 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 reassemble it all, and send it on and load it into memory so that the application can use it. The more fragmented a file is, the longer it takes to read the information from the disk. And likewise, when you're writing information, it's the same problem. If you have empty chunks of hard disk space and they're scattered all over the place, and you've got a large file that needs to be written, it's got to write a little information here, 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 over here. And every time it has to spin that hard drive, move those heads to get to that empty spot to write the information. Again, it slows things down. In order to fix this, we need to defragment the hard disk drive. When we defragment the drive, what we do is take all the chunks of the same file, such as these four right here, and instead of spreading them all over the hard disk drive, we put them in contiguous blocks like this. Now they're still separate chunks, but they're right next to each other. That way, when the system goes to read information here, it just says, read this one, read this one, read this one, read this one, read this one. And the disk doesn't have to spin very far, the head doesn't have to move very far to pick up each of those different chunks. Likewise, when writing, instead of going, okay, well, I can use this spot or this spot and this spot and this spot, the disk controller can say, okay, let's just start writing right here, and we'll write right here, we'll write right here, we'll write right here. Saves time, the disk doesn't have to work as hard, and your system works faster. So defragmentation is the process of moving or rewriting parts of a file to contiguous sectors on the hard disk drive itself to increase the speed of access and retrieval. And you can do this using the defragmentation utility that comes with Windows. It will go through and look at all those different pieces that are scattered all over the hard drive and rearrange your hard drive in such a way that the different pieces of the file are really close together, thereby increasing your retrieval speed. Now, another thing you can do to optimize your hard disk drive, your storage devices, is to scan your disk for errors. You can use the error checking utility found in Windows to check for file system errors and bad sectors on your hard drive. Your error checking tool looks for and fixes two different things. Number one, it looks for lost clusters. A lost cluster is a series of clusters on the hard disk drive that are not associated with a particular file. There's data there, but it's unknown as to what file that data belongs to. Somewhere along the line, something got messed up, and the file name was lost. These are called lost clusters. Your error checking tool looks for those and tries to repair them. Usually it can repair them, sometimes it can't. Frankly, if you're in a situation where you can't resolve the file name, usually means you've got some serious disk errors and you're going to be losing some data. Usually, however, though, it can figure out where those lost clusters go. The second thing that your error checking utility checks for are cross-linked files. A cross-linked file occurs when two files try to claim the same cluster. This is shown right here. Notice we have two files right here. We have your file.txt and her file.txt. Both of these files claim that this particular cluster right here is a part of itself. So, your file says, I have this cluster and I have this cluster, and her file says, no, actually I have this cluster and I have that cluster. Which of those does it actually belong to? Your error checking tool will look for cross-linked files and fix those. So the question is, how often should you perform these procedures? Well, from the hardware perspective, you're probably not going to be upgrading your hard disk and your disk interface very often. A, it costs money, and B, it takes time. But some of the tasks that we've talked about that are done from the operating system perspective, such as cleaning up your hard disk drive, defragmenting, scanning the disk for errors, those things are very easy to do. They don't cost anything. And while they do take some time, they can be done during off hours. I would highly recommend that you perform these procedures on a very regular basis and do them frequently. Now, how frequently depends. It depends on how heavily the system is used. If you have a very heavily used system, you might want to run your error checking scan, your disk cleanup, and your disk defragmentation about once a week, maybe even more frequently. If it's a system that doesn't get used all that heavy, then you could probably get away with doing this once a month. But again, do it on a regular basis, because doing so will keep your hard disk drive optimized and running at the best possible speed. In this lesson, we talked about things we can do to optimize our storage devices. We talked about upgrading our disk hardware and our disk interface to the fastest possible. We talked about cleaning up our hard disk drive using the disk cleanup tool. We talked about defragmenting our hard disk drive, and we talked about scanning the drive for errors.